Okay, so we've got this thing called a recurrence relation. So all that means is that a mathematical rule is used to generate a sequence. So when we had that before, when I had that 2, 4, 6, 8, that's a recurrence relation because there's a rule that's creating the next sequence, okay? So recurrence relation means we're creating a rule to make a sequence of numbers. So when you have a recurrence relation, and now this is going to be important, so when they ask you in your VCE exams to write a recurrence relation, you will always have to put these two things. So you always got to have the starting point. Now you're going to notice we're going to often call this starting point, and let's write it in there. We're going to call it VO. So you're going to see a lot of it. They might use another letter and, they'll call it O, meaning before, you've applied any rule. It's your beginning number, so at 0. But we often use it VO, and I'm getting used to it because it's value. So your value at the start, which means 0. And then we have a rule. So often the rule will be written like this. So they'll like Vn plus 1 equals, and so let's just write that this is an example. So Vn plus 1 equals, I'm doing the rule for this little sequence we've done up here. Okay, so I'm going to say Vn, and then we're going to plus 2. So you're going to see this a lot. Don't stress out. All this is like a label to say how to get the next term. So does that make sense? So I know when I see this n plus 1, I go, right, this is how I get, this is the rule for the sequence. And CVN just means you use the term before, okay? So here, obviously, if I was at 2 and then I add 2, I get 4. So 4 is then my next value, so that would be your VN. So then you got 4 plus 2. So that just means the term before. So it doesn't have any mathematical thing, it's a label, yeah? Can you see that the little letters here, this n plus 1, it'll be written smaller, but it doesn't mean anything mathematically. It's just a label. It's how we label it, okay? And the same with this, it's just a little label, okay? So it's not power or anything like that. So in this example, that was our rule, and also we'd write our VO, we'll say is 2, because it was the first one, okay? So that's what you need when they ask you to get a recurrence relation. We'll get really used to it, don't worry. So let's go. So Vn, just to go over this bit, so Vn could be used to symbolize the term in a sequence after n alterations. So say all that means is, if I said over here, talking about our example, if I said V3, see it'd be 1, that's 0, 1, 2, 3. V3 would be number 8, yeah? Because you see we're calling this the 0 term, then 1, 2, 3. So the third term, so it just means, maybe we'll just write that, it means the third term in sequence, okay? All right, so we've got another example here. They said if they give me a starting value of 10, and then they're telling me the rule is to add 5 to the current, so I'm just changing that to a mathematical, add 5 to the current term. So this is how we would write a recurrence relation. So if they said, can you write a recurrence relation for that? You will write VO, put your starting point. So they'll tell you this is the starting point. So we write VO equals, and then we have to write the rule. So it'll be Vn plus 1 equals. Now we just have to say what we have to do. Now because we have to add 5 to the one before, this is how we write that. We do Vn, which means like the term before, and we add 5. okay? So down here, we've got another example here. It says a sequence is generated by the recurrence relation. So they've called it a recurrence relation because they're writing it like this. VO equals 300 and VN equals this. So what does this actually mean? Here we've got to multiply by 0.5, the term before, and then subtract 9, okay? So, and it says, here's the recurrence relation, and it says write down the first 5 terms. Okay, so we call this one, we're calling this one VO, so that's the initial. So we'll call this V1, V2, V3, V4. Now, because that's like the value for the rule, but what they often say is that these are the terms. We still called, so these were terms. So we got 1, 2, 3, 4, 5. So they're including the first one in their term. That can be a little bit deceiving when it's asked, so don't worry, it will be a lot more clearer, okay? That one's a little bit vague because some people will be going, well, do I call it V0? We do call it a term, but it's still not. If you were asked to find the 5th value, you'd have to go one more, all right? Okay, so let's go practice this on our calculators. So I'm just going to pause it. Okay, a sequence is generated by the recurrence relation. So remember, I'm going to keep saying this so you can remember for year 12. So a recurrence relation just means they give you the initial and they give you a rule. That's why it's a recurrence relation. All right, it says use your calculator to generate, oh, we just did this. Yeah, generate the sequence of the thing. So we just did this. So what you want to do is sometimes, I know they say calculator. In year 12, they're going to say use your calculator to generate how many terms of the sequence are positive. So anyway, so what you have to do is show calculations, and I'm going to show you how we're going to write that out in our books. Okay? So what you do is you write, you can write 300, and then you have to write what you do. So you write that, say, V1 equals 300 times 0.5 minus 9, and then we'll just put the answer, which was 141. Then we'd say V2 would be 141. So I'm just doing the one before. So you can copy off your calculator because we've got this there. V3 would be 61.5 times 0.5 minus 9 equals 21.75. So we've done this on our thing. So you see how I'm always using the one before? That's what, that's what the calculator's doing, which we want it to do. And then if we go down to V5, we get, it's finally going to be a negative number. So you can see that here, we get negative 8.0625. All right, so the question was, how many terms of the sequence are positive? So 1, 2, 3, 4, 5. 5 terms are positive.